Welcome viewers, in this video we will see the solved problem in the dual network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Draw the dual network for the following network given. So this is the network given in the problem. We need to draw the dual network. This black color is the original network. The red color is the dual network. So here we have the current source available. Resistor, inductor, capacitor are connected in parallel. So the step 1 is we need to put the dot in the every loop. We need to identify the loop. In every loop we have to put the dot. So here 3 loops are available. This is the first loop. Current source and the resistor. Current flowing through this. This is loop is nothing but a closed circuit. This is the second loop. Resistor and inductor. Current is flowing through the resistor and inductor. This is the third loop. Inductor and capacitor. So 3 loops are available. So here the dot is placed in the first loop and is numbered as 1. Another dot is placed in second loop, is number 2. And dot is placed in third loop, numbered as 3. So 3 dots are available as 3 loops. And one more dot is placed outside the network. That's 0, numbered as 0. This is a reference node. This is a reference node. So the step 1 is every loop we have to put the dot, and one more dot is placed outside the loop, that is a reference loop, reference node. Now we need to connect all the dots. First we will connect dot 1 and 2 through the elements. So the dotted lines are drawn between the point 1 and dot 1 and dot 2. They are crossing through the resistor. So this resistor will be converted into conductance. Resistance will be converted into conductance G. So dot 1 and 2 is connected, through which we have resistor that is converted into conductance. And dot 2 and 3. The dotted lines are drawn between dot 2 and 3 through the inductor. So this inductor will be converted as a capacitor. L is converted to capacitor C. Then 3 and 0. 3 and 0 we have capacitor. The dotted lines are drawn between point 3 and 0 through the capacitor. So this capacitor will be converted into inductor in the dual network. Right. Now 1 and 0 we have the current source is available. Right. So the current source is available through that. So 1 and 0 is connected. So this current source will be converted into voltage source. Right. Now see the current direction. Current is going upward. So this end is positive and this end is negative. Right. So 1 and 2 resistor converted into conductance. 2 and 3 inductor converted into capacitor. 3 and 0 capacitor converted into inductor. 1 and 0 current source converted into voltage source. Now this red color line is nothing but the dual network. Black color is the normal original network. Now we'll draw the dual network separately. So what we need to do, we have to put the dots in a paper. 1, 2, 3 and 0. We have to put the 3 dots. Between 1 and 2 we have conductance G. 2 and 3 capacitor C. 3 and 0 inductor L. 1 and 0 voltage source V. Now we need to connect all the elements. So in original network, resistor, inductor, capacitor connected in parallel. In dual network, conductance, capacitor and inductor connected in series. Voltage, their current source converted into voltage source. So this is the dual network for the given original network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.